Okay, now we're going to use what's called implicit differentiation. And there's a couple different strategies that you could use to start off with. You could get the x squared and the 3y squared both to one side with the 2 to the side by itself. You could just leave it as it is, but this is when you use implicit differentiation. Remember, regular differentiation is when you've got this continuous function. Or at least within a certain domain, you've got a function that is continuous. Implicit differentiation is when you don't have a function. So think about this. If you've got a circle, that's not a function, because if you do the vertical line test, which tells you when something's a function or not a function, this vertical line will hit the circle in 2 places. Okay? And then the other reason it's a problem is, let's just think about taking the derivative. Let's take this right here. The slope of that line. Well, on a circle, there's going to be one other place. There's 2 different places where you're going to have a tangent line. So which one will you be talking about? So because of that, you have to use this new technique called implicit differentiation. And so what I'm going to do first is I'm going to get the constant number 2 by itself. That's all I did. I got the 2 by itself. And then we're going to differentiate both sides. So notice, I said, hey, big announcement. D over dx means I'm going to take the derivative of this, subtract the derivative of this, and that's going to equal the derivative of this. That's all. That's all I did with that right there. Here's where the tricky part comes in. So the derivative of x squared is just 2x. And then there's a subtract sign. The derivative of 3y cubed that's a 9 right there. It doesn't look like it. Looked like an A. 9y squared. But we're in trouble. That's not an x. So all we can do right there is we can say, and we have to take the derivative of times the derivative of the y. Okay? And then the derivative on the right side, the derivative of a constant is 0. Well, our whole objective is to get this by itself. So how do you get this by itself? Well, you cancel out a positive 2x by doing what? Yep, subtracting it both sides. And then, remember, we want to get this by itself. Well, negative 9y squared is attached by multiplication. So we're just going to divide both sides by the negative 9y squared. And then the very last thing you're going to do is just simplify. So here is our implicit. And notice we have both an x and a y value. And think about a circle. Remember cover this stuff up. The equation of a circle is x squared plus y squared is equal to r squared. So in implicit differentiation, typically what you're going to see, not always, but typically you're going to see 2 different variables involved when the function itself, or when the equation is not a function. It's a circle or a sideways parabola, an ellipse, a hyperbole, or something like that. And I think that's it for this one.